Hey guys, this is Sarkar and I am going to teach you economics. So today's topic is Marshallian demand, Hicksian demand, indirect utility function, expenditure function, Roy's identity and Shepard's lemma. So welcome to our second class of mathematical economics practice session. Today I will give you just the flowchart of how to derive Marshallian demand, Hicksian demand, how to derive them indirect utility function, etc. So in our economics we have two motives: to maximize our utility and minimize our expenditure. So first is maximize our utility and minimize expenditure, right? So when we try to maximize our utility, we have a constraint, that is our budget. So subject to our budget constraint. Now when we try to minimize our expenditure, we have a constraint, that is our utility. So if we see graphically how it looks, we have a budget constraint. So this is budget constraint. Now we have to maximize our utility. So utility is given by ICs, indifference curve, right? So when our IC will be maximum subject to this budget constraint, when our IC is tangent to our budget constraint. So our ICs may be like this, this, this. So this is the tangentship point. So this is our optimum solution, right? So this is our so this is our Marshallian demand. So by solving this we get Marshallian demand. Now our Marshallian demand is a function of price and income. So our Hicksian is a function of price and income. Now if we put this Marshallian demand back into a utility function, then we get indirect utility function. So this is also a function of price and income, as our Marshallian demand is the function of price and income. Cool. Now let's see for the expenditure part. So graphically, so here our constraint is utility. So we have an IC. Now we have to minimize our expenditure. So our expenditure curve like this, or like this. So this is the tangentship point. So this is our optimum solution, right? So by solving this we get our Hicksian demand. Now our Hicksian demand is a function of price and utility. So now putting this Hicksian demand into our expenditure, we get expenditure function. Now expenditure function is a function of price and utility, as our Hicksian demand is a function of price and utility. So now if we have been given indirect utility function like u equal to v m. Now they have told us to derive Marshallian demand. So how to derive this? Now xm will be minus by this formula we can derive our Marshallian demand. So I hope you guys know what is this. This is Roy's identity. So by Roy's identity we have to find our Marshallian demand from indirect utility function. And if we have been given our expenditure function as like this and told us to derive Hicksian demand, then we can so by this formula we can derive our Hicksian demand. This is known as Shepard's lemma. Now we can derive our Marshallian demand by another process, like we can just put this indirect utility function into Hicksian demand, so we can get our Marshallian demand. Now we have been given, let's say, equal to expenditure function as given. Now we can convert this into our indirect utility function, and if our utility function is given, we can convert it into expenditure function, then put this into Hicksian demand and we can get Marshallian demand. So we'll see how it works in sums. We'll do sums today, so don't worry. Now we can see that we have been given a question where it says maximize utility equal to xy subject to budget constraint m equal to px into x plus py into y, and we have to derive our indirect utility function. So how to do it? We'll do this by Lagrange. So first we'll write our Lagrange equation, which is xy plus lambda m minus px into plus py into y. So then we'll partial differentiation with respect to x, y and lambda, and we'll try to solve for our Marshallian demand of x and y. So first we'll do partial differentiation with respect to x, so it will come y as is, so this term minus px into lambda equal to 0. So now simplifying this, we get y equal to px, and now we'll differentiate partially by y, so it will come to now I am taking this as equation 1 and this as 2. Now dividing 1 by 2, we get y by x equal to px into lambda by py into lambda. So this lambda gets cancelled and we get a relation between y and x. Now we'll need this equation, so I am just erasing this portion. Now we have to differentiate partially the Lagrange equation by lambda, so we get m minus px into x minus py into y equal to 0. Now putting this value of y in this equation, we get now this py and py gets cancelled, so m minus px into x minus px into x equal to 0, or m equal to 2 px into x and we get x equal to m by 2 px. So this is our Marshallian demand of x. Now we can similarly get for y. So y, it will be, just put this value of x into this, we will get m by 2 py. Now we got the value of x and m. Now we put this value into this maximizing utility function to get our indirect utility function. So our indirect utility function will be xm into ym. This will come to m by 2x into m by 2 py, which will come to u equal to m square by 4 px py. So this is our indirect utility function. So now we have a question on our expenditure function. So we have to derive Hicksian demand, indirect utility function and Marshallian demand. So I have told you how to derive Hicksian demand by Shepard's lemma. Now how to derive indirect utility function from this, by just writing this equation in terms of u, and we can derive Marshallian demand by Roy's identity or by putting this indirect utility function in Hicksian demand. Right? I have told you this before. Now let's do the sum. So our Hicksian demand will be derived from Shepard's lemma, right? So we'll just partially differentiate this with respect to P1, so we get 1 by 4 P1 1 by 4 minus 1 into P2 1 by 4 U. So this comes to 1 by 4 into P2 1 by 4 into U by P1 3 by 4. So this is our Hicksian demand for x1, and x2 Hicksian demand will be one by 4 P2 1 by 4 minus 1 into P1 1 by 4 U. So it will come to right. So this comes our Hicksian demand for x1 and x2. We will just write these values so that we can use this later. Now we have to derive our indirect utility function. So this is our expenditure function, so we can write utility function like this. By taking this P1 and P2 in the denominator, we get our indirect utility function. So this is our indirect utility function. Now we can derive Marshallian demand by putting this utility function in Hicksian demands. So we'll just do this first, then we'll try Roy's identity, right? So it will come to P2 will be, so E by 4 P1, as 3 by 4 plus 1 by 4 will come to 1. So this is our Marshallian demand for x1. Similarly, we can just put expenditure function in x2's Hicksian demand, and we will get x2m equal to E by 4 P2. So this to our Marshallian demand. Now we'll try to derive Marshallian demand by Roy's identity. So we know that our Roy's identity formula for x1 is minus del u by del e1 by del u by del m, right? So we'll just differentiate this with respect to P1 first. So u equal to E P1 minus 1 by 4 P2 minus 1 by 4. This is our indirect utility function. So by del P1 it will come to minus 1 by 4 P1 minus 1 by 4 minus 1 into P2 minus 1 by 4 into E. So it will come to minus 1 by 4 P1, this will come to minus 5 by 4 into P2 minus 1 by 4 into E, right? And if we differentiate, sorry, not M, we will just differentiate with respect to the E, as we have given E here. So we differentiate with respect to E. So it will come to P1 minus 1 by 4 P2 minus 1 by 4. Now putting these two terms in Roy's identity, we get Sorry. So minus 162 plus E by 4 P1 5 by 4 into P1 minus 1 by 4, it will become to E by 4 P1, right? So this was the same value as we get by putting this utility function or indirect utility function into Hicksian demand. So similarly we can derive for x2, it will again come to E by 4 P2. So I hope you guys have understood all the things here, and if you have any query, just put your query in the comments, or you can contact me on my WhatsApp. I will just put my number in the description.